Hello everyone, this is Adnan and welcome to Chemistry with Adnan. On this YouTube channel, I'm covering the entire syllabus of IGCSE Cambridge Chemistry. The course code is 0620. I also offer one-on-one and group lessons on my community, which is called High School Chemistry on school.com. The link is given below in the description. You can join it for free, where I offer, one lesson free, per month, and I also offer group lessons, like 4 lessons per month, right? So one per week. So it is an interesting place to be if you are learning chemistry, and you can ask questions, you can interact with other students, you can share your learning strategies, and yeah, and like all things related to chemistry, you will find there. So in this lesson, we are covering 7.1. This is chapter number 7, acids, bases, and salts. So 7.1, it says that the characteristic properties of acids and bases. So the first topic for core students, for the core syllabus, it says that describe the characteristic properties of acids and in terms of their reactions with metals, that how acids they react with metals, how acids they react with bases, and how acids they react with carbonates. So before jumping into this discussion, let me explain what basically acids and bases are, right? So acid is a chemical that has a pH less than 7, right? So the pH is a scale which determines whether something is an acid or a base. It starts from 0 and goes all the way to 14. So on this scale, there are many methods to calculate the pH. Sometimes we use a universal indicator. It's a paper which changes color depending on the pH, right? And pH can be detected or calculated by using a pH probe or pH meter. It's an electronic device. We dip a metal rod into the solution, and the digital meter, it will give us a reading that what the pH is, right? So it will have a screen, and it will tell us that what the pH is. So acid, anything that has a pH less than 7, it is called acid, right? So and 7 is neutral, and anything above, with a pH of above 7, that is a base. So and then what is a salt, right? So when a salt is a compound formed when the metal ions replace the hydrogen ions, like for example, uh, um, you know, so HCl, for example, that's an acid, right? So a metal, let's say sodium, when it replaces hydrogen, so it's going to change into NaCl, right? So what is a salt? It is a product of a neutralization reaction. When acid reacts with metals or when acid reacts with a base, so salts are produced, right? So we will talk about these in detail in this lesson in our upcoming topics. But let's stick to this, that a salt is a product of a neutralization reaction when acid reacts with a metal or a base, right? And or a carbonate as well. Anyways, so now let's take a look at, okay, so some of the acids that you need to know are HCl, hydrochloric acid, a nitric acid, HNO3, and sulfuric acid, H2SO4. So you should remember their formulas, you should remember their names, right? Okay, so now let's take a look at their reaction with the metals, right? So remember that whenever an acid reacts with a metal, right, it's going to produce a salt, and a hydrogen gas will be released. uh, Hydrogen gas, right? So this is a general word equation. Now let me give you guys a symbol equation. So sodium, for example, a metal in a solid state, when it reacts with HCl, hydrochloric acid, in its aqueous state, so it's going to produce salt, sodium chloride, and this is soluble in water, so we write AQ, and hydrogen gas will be released, right? So, and I write a state symbol of a gas here. So this is the equation. Now, depending on this acid reacting with the metal, we can have three types of salts, right? So HCl will give us chloride salt, metal chloride, right? Nitric acid will give us a nitrate salt, metal nitrate, and sulfuric acid, H2SO4, that is going to give us a sulfate salt. So let me write the examples here. So Na, sodium plus HNO3, right? So this is going to give us sodium nitrate, NaNO3, right? And hydrogen gas. Similarly, when sodium, it reacts with the sulfuric acid, H2SO4, so that is going to produce sodium sulfate, Na2SO4, that's a sulfate salt, plus H2. So, okay, let me balance this equation, the first one. So I will have to put 2 here, 2 here, and 2 here. Okay, now the equation is balanced, right? So now the second equation, I'll have to put 2 here, 2 here, and 2 here. Now this one is also balanced. And now the second one, I'll have to put, the third one, I'll have to put 2 here. And I believe that is it. Yeah, the equation is balanced. Yeah, so this is how acid or acids, they react with metals, right? So if it's lithium, so you just have to replace the sodium, so it will be lithium chloride. If it is potassium, so the salt form will be potassium chloride. Here, if potassium is reacting with nitric acid, so we'll get potassium nitrate, right, instead of sodium nitrate. So yeah, so you just have to replace hydrogen with the metal, right? So, and you will be able to write the product. So you can see here, and here, because sulfate, you should know that sulfate. Okay, let me write the symbols of these ions. Chloride is Cl negative, nitrate is NO3 negative, and sulfate is SO4 2 negative, right? So if sodium has to combine with sulfate, so we must have 2 sodium atoms to apply the crisscross method and to cancel the charges. So Na plus 2 sodiums, they will neutralize the -2 charge on sulfate, right? So it will be Na plus and SO4 2 minus. So remember the crisscross method. So the formula will be Na2 SO4, right? Sodium has a +1 charge because it is from group 1, and group 2 elements, they have a charge of +2. So the ratio will be 1 to 1. For example, magnesium, Mg2 plus SO4 2 negative. So it will be MgSO4. I hope this is clear. So now we move on to the next one. Now we take a look at their reactions with bases, right? So what is a base? I have explained that base is a chemical compound that will have a pH greater than 7, above 7. So base equals to pH greater than 7. And yeah, so we have different types of bases than the ones that you need to remember or learn are, metal oxides, metal oxides. So, what are metal oxides? Compounds of metals with oxygen. For example, magnesium oxide or sodium oxide, right? And yeah, like the calcium oxide and so on. So these are called metal oxides. These compounds, they can behave as a base. And other than these, uh, metal hydroxides are also strong bases, right? So what are bases? Metal oxides and metal hydroxides. So metal hydroxides. Yeah. So what are but hydroxides means OH negative ion. So NaOH. So that is a base. Sodium hydroxide, lithium hydroxide, potassium hydroxide, and magnesium hydroxide. So now you can see that I am attaching two hydroxide ions with magnesium because it is from group 2 and it has a +2 charge. So to write the formula of magnesium hydroxide, I must add two OH negatives to neutralize the charge and to make it equals to 0. So I hope this is clear. Now let us see that how acids they react with bases. So I need more space here. I need to hold on. Uh, this is going to be a long video because or a long video lecture because we have lots of topics to cover, and I'm attempting to cover topics of core and extended supplement syllabus in the same video lecture. Okay, so this is acid and metal. So now acid plus base, right? Okay, now the general reaction is a neutralization reaction. Whenever acid reacts with a base, salt and water is produced, right? Salt plus water. When base is a metal hydroxide, but when it is when it is a metal oxide, even then water is produced, right? So let me write down some examples. So for example, magnesium oxide, when it reacts with a base, sorry, that is a base, it reacts with an acid, for example, HCl. So what will be the product produced? Salt and water, right? So magnesium chloride, MgCl2 plus H2O, right? So you have to be very careful while writing the symbol equations, because and remember the charge on the ion so that you can write the correct formula, right? So magnesium chloride is not MgCl, it is MgCl2 because chloride has a Cl minus charge, and magnesium from group 2, it has a positive 2 charge. Okay, so how can you easily write the product? So most of the times, you have to combine a metal from a base, metal oxide, with a non-metal from the acid, right? And you can combine hydrogen and oxygen to make water. So this is how you can write down the products, right? So now another example of metal hydroxide, another type of base, that is sodium hydroxide, that is a base, plus acid HCl. So that's going to produce sodium chloride now, NaCl plus H2O, right? So this is the general equation, and here the products will be salt and water. And depending on the metal, the base, and the acid, we can have different types of salts, right? So now I have a question for you. For example, I'm reacting lithium with nitric acid, HNO3. What will be the product? So you can pause this video here and try to write down the answer. So, okay, in the meanwhile, I'll balance these equations. So I'll have to put 2 here, and the equation is balanced. And this one, it is already balanced. Yeah, and this one, the product will be lithium nitrate, right? So metal, okay, no, lithium oxide. So Li2O. So lithium nitrate, LiNO3 plus H2O, right? So I'll have to put 2 here, and then I'll have to put 2 here, and the equation is balanced. Yeah, 7 oxygens on both sides. So this is how so now that is called a nitrate salt, right? And if sulfuric acid reacts with lithium oxide, so the salt produced will be lithium sulfate. So I hope this is clear. Now we move on to the next one, which is acids. and carbonates. Acids plus carbonates. So when an acid reacts with a metal carbonate, so salt, water, and carbon dioxide is produced, right? Remember this, that this reaction, it is a bit different than the first two. So in the first one, when acid was reacting with a metal, salt and hydrogen gas was being produced. So let me highlight this. This is very important. If you just remember this, so you can write down the word and symbol equations. And for core students, the questions are, usually like very easy. And you just, I mean, the answer is given in the question. You just have to write the arrow, like the equation, the symbol equation with an arrow, right? Or a word equation with an arrow. So, and here, on this one, acids, when they react with carbonates, they produce salt plus water and carbon dioxide, right? Okay, so yeah. So now let me give you guys some examples here. And when sodium, okay, carbonate. So acid, let's say HCl is an acid, and we are trying to react with a carbonate. So carbonate means a metal carbonate, right? What is carbonate? A carbonate is a polyatomic ion, CO3, with a charge of 2 negative. So we can have metal carbonates like Na2, CO3, lithium carbonate, magnesium carbonate, right? So you can see again that how the formula changes as we move on from group 1 to group 2. So group 1 metals, this will be X2CO3, right? X can be any group 1 metal, and like sodium, lithium, rubidium, potassium, anyone. And for group 2, you can see that I'm writing MgCO3 because both of them, they have the same charge. Magnesium has a +2 and carbonate has a -2. So I hope this is clear. I am emphasizing a lot at this point, a lot. So you have to be very, very careful, because this is the area where students make most of the mistakes while solving these questions. So sodium, like HCl, a carbonate, let's take a metal carbonate. So Na2, CO3. So the salt produced will be sodium chloride, NaCl, plus water, H2O, and yeah, and CO2, right? So we can balance this equation. So we have 2 hydrogens on the right, I'll put 2 on the left. Now I have to balance chlorines, so 2, and that's it. The equation is balanced, right? So again, if it's H2SO4, like sulfuric acid with a metal carbonate. Let's take another one this time. Let's take magnesium carbonate this time. So the salt formed will be magnesium sulfate, MgSO4, and this will be water, H2O, plus CO2, right? And to balance this equation, I think the equation is already balanced. Yeah. So this is how it works. Now, yeah, so we have covered all three. So the topic was that describe the characteristic properties of acids in terms of their reactions with metals, bases, and carbonates, right? So we discussed that what a base is, what an acid is, and what a carbonate is, and how acids they react with all three of them. So in our upcoming video, in our next video in the series, there will be an exclusive past paper practice based on 7.1, the characteristic acid properties of acids and bases, right? So you watch this video first, this lecture first, try to develop your understanding, and as we move on to the next video, then we will solve questions from the past papers, and then you can attempt the questions, and then you can watch my lecture. and you can compare your answers, right? And if you have any questions, you can leave them in the comments below, or you can join my community if you need one-on-one tutoring sessions or group lessons with me. So now we move on to the second topic, which is describe acids in terms of their effect on litmus, thymolphthalein, and methyl orange. Okay, so let's create some space here. And yeah, okay. So describe acids in terms of their effect. Okay, now what are these things? These are called indicators, right? So they are indicators, and they change color. They have a different color change, right? So in order to test for acids, an indicator can be used, and these change color in different solutions according to their acidity or basicity or alkalinity, right? So litmus, thymolphthalein, and methyl orange, these are the three different types of indicators that change color, and by the color change, we can identify that the solution that we are testing, whether it's acidic or basic, right? So let's take a look at litmus first. So litmus, it is available in aqueous solution form. It is a liquid. It can exist in a liquid state, right? And more commonly, it is also marketed as a paper. Like it is converted into a solid chemical which is applied on a paper. So if you dip that paper strip in a beaker, it's going to change color, right? So and it comes in two different forms, in paper form of litmus indicator. It comes in blue color, and it comes in red color, right? So now, when an acid is added, so and if you have a beaker, right, and if you have a blue litmus paper, and if you dip in this acid, I mean in this liquid, and if it changes red, if it changes from blue to red, so that means that the liquid is acid, right? And if you have a red litmus paper, and it remains red, so that is also an indication that the solution that we are testing is acidic in nature, right? So I hope this is clear. So now we move on to the next one, which is thymolphthalein. So uh, uh, thymolphthalein, yeah. So thymolphthalein is another indicator, right? And when an acid is added, so thymolphthalein will stay colorless, right? So it is colorless, and when acid is added, right? If you add acid, it will remain colorless. It will not change its color, right? So that is an indication that will be the effect of acid on thymolphthalein indicator. It will not change its color. So the next one is, uh, you know, the other one is methyl orange, right? So methyl orange, and methyl orange, when acid is added, it has an orange color, obviously, like you can see from the name, and its like actual state is orange, but when acid is added plus acid, so it turns red, right? It turns red. So from orange, it's going to change into a red color, right? So remember that. Okay, so these are memory-based concepts. You have to remember the color change, right? There's no concept involved. There's nothing that you can do You just need to remember that, what will be the observable change of a certain indicator when it is treated with acid, right? When it comes in contact with acid. So I hope this is clear. Now we move on to the next part. And topic number 3, state that bases are oxides or hydroxides of metals, and that alkalis are soluble bases. Yeah, so we have already discussed one part of this topic, that bases are oxides, like they are metal oxides, and they can be metal hydroxides. So we understand this. We just discussed it here while explaining topic number 1 and 2. Yeah, so these are, you see, these are bases, right? And the base that is soluble in water, so we have a special name for it, right? So remember, so soluble base, so we call it alkali, right? Yeah, so soluble bases, they are called alkalis. Okay, so I hope this is clear. And now we move on to the next topic. Describe the characteristic properties of bases in terms of their reactions with acids, ammonium, salts. Okay, now, like in our previous topic, in the first topic, we took a look at the reactions of acids with metals, with bases, and with carbonates. But here, we will be taking a look at the reactions of bases, right? Okay, so now, okay, describe the characteristic properties of bases in terms of the reactions with acids. Okay, so the same thing, we have already talked about it, and when acid, they reacts with a base. Acid plus base, it's a neutralization reaction, and salt and water will be produced, right? Salt plus water. So, but let's talk about ammonium salt. So ammonium, what is ammonium? Ammonium is a polyatomic ion with a positive charge. It is a cation. So NH4 positive is the formula of ammonium, right? So when this polyatomic ion, it combines with a metal, it creates salt, right? So we can have sodium, uh, you know, uh, and no, with a non-metal, sorry. So NH4Cl, that is ammonium chloride, right? Or we can have ammonium sulfate, right? These are all ammonium salts, right? Or we can have ammonium nitrate, right? And things like these, right? So acid and base. So now okay, so now ammonium salts base. Yeah, so sodium hydroxide, for example, when it reacts with an ammonium salt, so let's take ammonium sulfate, right? So ammonium sulfate, that is an ammonium salt. So that is going to make sodium sulfate and ammonium hydroxide, right? So Na2SO4, that's going to make a salt, and plus uh, you know, uh, NH4 or water and ammonia, right? Uh, NH3. So another example is ammonium chloride with Na sodium hydroxide. Yeah, so NaOH plus ammonium chloride. So that is gonna make, uh, you know, sodium chloride, a salt, plus water, plus ammonia, right? So the general equation for ammonium salts will be an ammonium salt plus base. You will get three things: a salt plus water plus ammonia gas, right? So yeah, so this is the general equation. And now, depending on the type of base used and the ammonium salt used, we can write down the formula of the salt, right? That will be produced by this reaction. Okay, so now topic number 5. All the topics that we are learning in our upcoming video, in our next video in the playlist, you will find the questions from past papers exclusively on this topic, right? So yeah, we are still covering the core content. The first 6 topics are for core, and from topic no for first 8 topics, sorry, and then from topic number 9 to 11, they belong to the supplement syllabus for extended students. Okay, so describe alkalis in terms of their effect on litmus, thymolphthalein, and oh yeah, now alkalis are bases that are soluble in water, right? So now litmus, we already know that litmus comes in 2 different colors, blue and red. So blue litmus paper, when it comes in contact with a base or an alkali, right? So it's going to change its color to blue, right? And if it's a blue litmus paper, and if it comes in contact with an alkali, which is a soluble base, so it will remain blue, right? So uh, so you need to remember this, the color change or the properties, that how this indicator, which is called litmus, it will interact with a base or alkali, right? So thymolphthalein, so for thymolphthalein, it's going to turn blue. Remember that when we were adding acid to thymolphthalein, it stays colorless, but when or A, when B, thymolphthalein, that's going to change into blue, right? So from colorless to blue. So I hope this is clear. So let me just highlight these. So okay, this is blue. So red will change into blue, and blue will remain blue. And let me highlight this one as red. Yeah, and this one is also blue, right? From colorless to blue. So I hope this is clear. Now for methyl orange, the third one, methyl orange. So yeah, it is orange in color. So with acid, when it was interacting with acid, it was changing into red color. But when it reacts with an alkali, it changes from orange to yellow, right? So remember this, uh, you know, just like you remember, your name and, your home address and stuff like that. So on question number 6, topic number 6, uh, state that aqueous solutions of acids contain H plus ions, and aqueous solutions of, yeah, so now this is another definition of acids and bases. Initially, at the beginning, we defined acids as compounds having pH less than 7, right? And bases with pH greater than 7. So now we are expanding that definition, and acids and bases, they can be defined as the proton, the ions, their solutions, ions that they contain. For example, if we have a beaker, we have a solution, right, and it contains AH plus ions, or more than OH negative ions, so we will call it an acid, and it will have a pH less than 7, right? And we have another beaker, for example, where hydroxide ions are greater than the H plus ions. So this solution will be called a base or an alkali because it's soluble, and its pH will be greater than 7. So what is an acid? Acid is any compound that when it is dissolved in water, it releases H plus ions. In aqueous solutions means solutions of water, right? So H plus ions in aqueous solutions, and base or alkalis. Remember, base is not soluble in water, so alkali, it releases OH negative ions when it is dissolved in water, and we call that an aqueous solution. So I hope this is clear. And now we move on to topic number 7, which says that describe how to compare hydrogen ion concentration, neutrality, relative acidity, and relative alkalinity in terms of color and pH using a universal indicator paper. Okay, so a universal indicator paper, I already discussed, right? So it is a paper that can change 14 different colors. It can turn itself into 14 different colors. Now let's say we have different types of beakers. Like, so we have beakers with solutions of different pHs, right? So 1, 2. So hold on. Let me just explain this. 1, 2, and okay, I need to lock this layer. Uh, okay, yeah. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12, 13, and 14. Okay, so now let's say these beakers, in this beaker we have a solution with pH 1, right? Here we have pH 2, pH 3, 4, 5, 6, 7, 8, 9, 10, 11, pH 12, pH 13, and pH 14, right? Yeah. So now describe how to compare hydrogen ion concentration. Yeah. So as we are moving from pH 1 to pH 14, so remember, this is a very, very important point that we are about to discuss, that whenever when the pH increases, right, the concentration of hydrogen ion decreases. They are inversely proportional to each other, right? Remember that. And acidity also decreases, right? Since the pH is increasing, it means that the solution is going towards being basic or alkali in nature, right? So, and when it reaches 7, so the pH here, the concentration of hydrogen ions, they become equal to the concentration of the OH minus ions. So here the hydrogen ion concentration is very high, and we have a very, very small amount of OH ions present when pH is 1, right? And when it is 2, so the OH is a little higher, and then pH 3, OH is even more higher, right? It increases. And now when you surpass 7, when you cross pH 7, and when you move on to 8, now the H plus ions will be lower in concentration as compared to the OH negative ions. And when we move on to up to pH 14, so the OH negative become maximum, and there will be very, very, very few negligible amount of hydrogen ions that will be present at pH 14, right? So I hope this is clear. And yeah, so now universal indicator. Yeah, so if you dip this paper into this beaker, it will give you a different color. And then there's a card, which you can, and with the colors on it, right? So there will be a card, a reference card, a reference sheet, which will have different colors on it. So pH 1 will be indicated by some color. Let me show you. The universal indicator chart, right? Universal indicator chart. So hold on, let me take a screenshot and show this to you. Okay, here, let me paste this here. Yeah, so now you can see that if pH is 0, so it will this paper will turn red, right? And if you dip it in this beaker, so with the pH 2, it will turn into this color. If you dip it into a beaker in this beaker with the pH 11, so it will correspond to this color, right? And boil it like 14, it has a dark purple color, right? So this is how universal indicator, you see, in terms of color and pH using universal indicator paper. So it's a paper that can change into these colors depending on the pH of the solution. So I hope this is very clear. Now we can move on to topic number 8. And yeah, this is the last topic for core students. And the extended students, they can keep watching because like both core and supplement, they are included in their syllabus. So describe the neutralization reaction between an acid and an alkali to produce water. So yeah, so we have talked about it before, that whenever acid reacts with the base, it is called a neutralization reaction, and salt and water is produced. So that is the equation. This is very important. You will often asked to write down this reaction. So H plus from acid, since acid releases a H plus in an aqueous solution, and a base releases hydroxide in aqueous solution. So when their concentration is equal, like they will, join together to produce water, a pure liquid, and this will have a pH of 7, right? Pure water has a pH of 7, it is neutral. So this is called a neutralization reaction, and this is how we represent it using these ions or ionic equation. So now we move on to supplement topics. And yeah, so the first topic on the supplement is define acids as proton donors. Now, this is the third definition that we are learning about acids and bases, right? The first one was that acids, they have a pH of less than 7, and base is something with a pH of greater than 7. The second definition was that acid it releases hydrogen ions in aqueous solution, and a base or an alkali releases hydroxide ions in aqueous solutions. And the third one is that acid is a proton donor. So it's basically the same thing as, uh, yeah, as hydrogen, right? So let me just write this. Okay. Okay, so acid, it donates a proton, right? So why H plus is also called a proton? Because in hydrogen, we have just one proton in its nucleus, right? And we have one electron in its outer shell, right? Because its atomic number is 1, and atomic mass is also 1. So when this hydrogen is removed, this electron is removed from a hydrogen atom, so all we are left with a proton. So H plus is just a proton, right? So that is why the H positive cation, that is called a proton. So acid is anything that donates a proton, right? And donates proton. And base is anything that accepts it, right? It accepts a proton. So I hope this is clear. So yeah, So what will be the yeah, that's it. Like no need to go into the you know uh, chemical equations and stuff. So topic number 10, define a strong acid. Yeah, and what is the difference between a strong acid and a weak acid? So the definition is given. So this is what you need to remember literally, that a strong acid is something that dissociates completely, or is completely dissociated in the aqueous solution, right? And what is a weak acid? A weak acid is something that partially dissociates, right? So that is partially dissociated in aqueous solution. So let me put this in perspective. Let me give you guys an example. So for example, HCl is a strong acid, right? So when I put 1 mole of HCl molecules into this in water, so all of them, 100% of this acid, it will be converted into H plus and Cl negative. And in this beaker, we will not have even a single molecule as HCl. We will not have even a single undissociated as HCl molecule present in it. No, all of them will, quickly dissociate, break into, ionize into H plus and Cl minus. Now, a weak acid, for example, acetic acid, vinegar, CH3COOH is a weak acid. And since weak acids, they partially dissociate, so we mentioned this reversible arrow, this symbol for the reversible reaction, and it will change into CH3COO negative and H plus. After all, it is an acid. Even though if it's a weak acid, it would still release some, protons or hydrogen ions. So, but their, uh, concentration in the beaker will be very, very, like, will be negligible, right? So most of the acid will remain undissociated in this beaker, and there will be very few acetate ions and protons in this beaker. So that is the difference between a strong acid and a weak acid, right? So I hope this is clear. Now, the second last topic is topic number 11, which states that hydrochloric acid is a strong acid as shown by the symbol equation, right? So yeah, we have already talked about this, right? So, and state that at the ethanoic acid, wow, so it's a weak acid, and it is shown by, and this is the symbol that we must represent this equation with, because this is a partial dissociation, and it achieves equilibrium, right? And at equilibrium, the concentration of the undissociated acid will be higher than the product's concentration. So I hope this is clear. This was the first topic of this chapter, acids, bases, and salts. 7.1, describe the characteristic properties of acids and bases, right? So our upcoming lesson in the playlist, now, whatever we have learned in this lesson, now we will see that what type of questions we will be asked on the exam, right? So don't forget to like, subscribe, and share with your friends. And for one-on-one or group lessons, which are very, very economical, you must visit the link given in the description, my community, high school chemistry on school.com, so that you can interact with me directly live in these lessons, and you can ask me questions directly, right? So good luck, and I'll see you in the next one. Take care. Have a good day. Goodbye.